Hello, in our last lesson, we have discussed about velocity and acceleration. So velocity is a derivative of the position and acceleration is a derivative of the velocity. And today, we are going to discuss about another very important applications, the extreme values. Extreme values means maximum or minimum values. And for a function, it may have the local maximum or local minimum. So this one is a minimum at these intervals, but it's not the absolute minimum for the whole function. So this one, the lowest point is we call absolute minimum, and the highest point we call it absolute maximum. So absolute maximum is a local maximum, but also it is a absolute maximum. So local minimum, this point is not absolute minimum, but this one is both absolute minimum and also local minimum. Okay. So we are going to continue and also absolute maximum, we also call it global maximum or global minimum. And the local maximum minimum also we could call it relative minimum. It's not absolute. And this is called boundary point. Sometimes if the boundary point is the highest point, it could be the absolute maximum or minimum. It's not going to be the, and also it depends on the functions. Okay, so here are some examples in this chart. So function f is continuous function on the closed interval from a to b. So the squared bracket means include point a, x equals a, x could be equal to b. Then f has both an absolute maximum or absolute minimum. So as long as continuous, it must have the maximum or minimum, highest point or lowest point in this interval as long as function is continuous. So for example, this one, you have a maximum here at x equals c. This one is at ending point, x equals c. You have absolute. This is at middle, so only have one maximum. And for this one, every point is a maximum or minimum, is a constant function. And for the minimum, it's here. This one is at middle. This one is at end point. So in this lesson, what we are going to see is we want to find the local maximum, local minimum, absolute maximum, absolute minimum. Okay, so we are going to practice on two types of questions. One is graph given, another one is expression given. Okay, so if we want to find the maximum minimum values algebraically, how are we going to find it? You will see that the maximum, minimum, it happens at the slope is 0. So what we are going to do is just find the derivative and let it equal 0 to find the possible maximum minimum point. So if it's inside the interval, this point you have the slope equals 0. So all the possible slope equals 0 may be the local maximum or minimum. So that's reason for if we do it algebraically, first thing we want to find the derivative of the function f at x, and let it equal 0, solve for all the possible x value. And also we find the function value at the endpoint. Then after that we compare all the values, then we are able to find the absolute maximum, absolute minimum. Okay. So now we have one graph given here. So this is a function f of x, and the function f of x is continuous. A continuous means you could use a pen to trace this function without lifting your pen. So it's continuous. It doesn't mean it is differentiable. So at some points, if not differentiable, you may still have the maximum or minimum. So it will be discussed in future, but in this lesson, we are going to deal with all the function is differentiable, find f prime x equals 0, then find the maximum minimum. And in future, we are going to discuss about what if the f prime doesn't exist, then we need to find those key points and to find the maximum or minimum. Okay, so in this lesson we just focus on is differentiable. Okay, and from graph it could be not differentiable. So for this point it asks you, it is select all that apply. So it's a global maximum, global minimum, local maximum, local minimum, or neither. So from this graph, we are going to see this point is the lowest point. So for lowest point, we know that is a minimum. And this is a global minimum point. So it is an absolute minimum. Also we call it global minimum. And all the global minimum or absolute minimum, they are the local or relative minimum. So we pick these two. So local minimum is not global minimum, but global minimum is a local minimum too. So global also we could call it absolute, and the local relative. Okay, so this is from graph how we can tell the minimum or maximum. And also from this graph, although it didn't ask us to determine the other points, but we want to just practice more. So this is for this point is not the lowest point, but here at this interval is a minimum point, so we call it local minimum. And this point, not the highest point, so it's local max. And these two is just an end point, so it's end point. So we don't call it is a local maximum or minimum. It's their end point, and from here is the highest point for the whole graph, so we call it absolute maximum or global max. So sometimes there's a little bit confusing. So we know that global maximum, we also call it local maximum. So we could call this one is a local maximum too. So that is how we find the local minimum, local maximum from a graph. Then next example, we are going to see how we can use an algebraic method to find the local minimum, maximum, and absolute minimum, maximum. So find the extreme values of this function on the interval x belongs from -1 to +5. So in order to find the extreme values, we know we want to find where the slope is 0, where it tends. So sometimes you have slope of 0, it may not be the local maximum minimum. It's just a kind of here, it just turn a little bit and continue. This one is not a minimum or maximum point. And we are going to discuss in future how to determine the absolute minimum or maximum. It's not only f prime equals 0 enough. We need to continue. That is our next lesson, okay? So in order to know its minimum, maximum, we also need to see if the f prime change sign or not. So this slope positive, this slope is negative. You change the sign, then here's the local maximum, minimum. So it means when you change the sign, f prime equals 0 and f double prime. So f double prime is find the 0 point. So this is positive, f prime positive. This part is f prime negative. At changing from positive to negative, that point is our absolute, maybe our absolute maximum or minimum, but that is our next lesson. So this lesson, we are going to just focus on the first derivative equals 0. So f prime at x equals 0. So we solve for the f prime. So we do the derivative to this function. So -2 times 3, then x to the exponent 3 minus 1 is 2, plus 9 times 2, x to the exponent 1, then constant is 0. Constant derivative is 0. So -6x squared plus 18x equals 0. So this is a quadratic equation, and we have the common factor -6 and x we can take out. Then each term is going to be divided by -6 and x. So both divided by -6 and x. Then -6x squared divided by -6x, we have x left. 18x divided by -6x, we have -3. We have these 2 times. It means each of them is a factor. So 2 things times together equals 0. Then either of them equals 0. Then times will give you 0. So each factor we let it equal 0. Then we solve for the x. -6x equals 0. Isolate x, move the -6 to other side. Here, be careful, is multiplication. Opposite operation is division. So we divide -6 to both sides. -6 divided by -6 is 1x. 0 divided by -6 is 0. So this is a solution for the first linear equation. Then for the second one, isolate x, move the -3 to other side. Opposite operation is +3. Then we have x equals +3. So these 2 points will be the turning points on the graph. So now we are going to, so this is a step 1. We solve for the derivative equals 0. Then step 2. Step 2, we are going to find all the f at x at f prime x equals 0 and also the end point. So we have to compare the local or maximum minimum possible maximum minimum point with the end point, because sometimes you have these two local, but you have other endpoints. Although the f prime is not 0, but they may be the absolute maximum or minimum. So this is a -1 start to +5. Then we have other 2 point is 0 at 3. Okay, so we sub x equals 0 into f at x. We have f at x equals -2x cubed plus 9 times 0 squared plus 4. Then do the calculation, you will find out it equals 4. 0, 0, 0 plus 0 is 0, so it's 4 only. Then x equals 3. f at 3 equals, change the 0 to 3, -2, 3 cubed plus 9 times 3 squared plus 4. Exponent, do it first. -2 times 27 plus 9 times exponent first plus 4. Then we do the multiplication. After that, the final answer we have 31. So this is a 2 f prime x equals 0 points, and also we find the endpoints. So x equals -1 sub in f at -1 equals -2 -1 cubed plus 9 times -1 squared plus 4. You don't have to show me all those steps. You could just do all the calculation, get the final answer right away. So this one, -1, so -2, -1, this is a +1, 9 times +1 is 9 plus 4, -1, negative, positive, so 2 plus 9 plus 4 is 15. Then x equals 5. So f at 5, sub in, we replace all the x with 5. Then get your calculator out. The final answer, is -2. So we have -250 plus 225 plus 4, we have -21. Then we are going to compare. So we compare all those y values. So we have 4, 31, 15, -21. Then the absolute maximum is 31. When x equals 31, x equals 3. Then the absolute or global minimum is, look for the number, is lowest number is -21 when x equals 5. So this is how we find the global maximum, global minimum. So you need to find the y value at f at x equals 0, and also the y value at endpoints. Then you compare all those points. So this 0 is 4, 3. Actually, I didn't graph it properly, so it's kind of. So this is another way. So -1 is 15. So go another way, 15. Then here is x equals 0 is 4. Then continue, 3 is 31. So we just find those points, graph it a little bit. So -1 is 15. Then 0 is 4. 3 is 31. and 5 is negative 21. So we connect all those points. It will be from here, go here, go up, then all the way down. So this is, if it's continuous, then it's kind of like this, if we connect them smoothly. So this is today's lesson, and what you have to know is find the absolute, maximum, minimum, local, maximum, minimum. Thanks for watching.